Today I am going to start a new chapter, that is damped and forced oscillations, which comes under module 1. So in that, first I will start with damped oscillations. Let us first know what is damping. So damping is the reduction in the amplitude of oscillation as a result of energy being drained from the system to overcome frictional or other forces. So then what is damping oscillations? So it is a type of motion executed by a body when it is subjected to the combined action of both resistive and restoring forces, and the motion is always gets terminated with the body coming to rest at the equilibrium position in finite interval of time. So that is known as damped oscillation. So let us see the examples. First one is mechanical oscillation of simple pendulum. Next one is when a swing left free to oscillates when it is pushed once. Next one is electrical oscillation in an LC circuit in which the circuit is closed just after the capacitor is charged. So these are the examples. Now let's see the theory of damped oscillations here. Okay. So here let us first consider a body of mass m executing vibration in resistive medium. So here the vibrations are damped due to the resistance offered by the medium. Since the resistive force is given by minus r into dx by dt, so which is nothing but the resistive force is directly proportional to velocity of the body. So here negative sign indicates the direction opposite to its movement. So this dx by dt is nothing but velocity of the body and r is the damping constant. So next, the restoring force is given by minus k into x. Now combining these two forces will get resultant force will be equals to minus r into dx by dt minus kx. Take it as equation number 3. Now from Newton's second law of motion, we can write the resultant force as m into d square x by dt square. Now from equation 3 and 4, we can write it as m into d square x by dt square is equals to minus r into dx by dt minus kx. Or we can write it as m into d square x by dt square plus r into dx by dt plus kx is equals to 0. So this is the equation of motion for damped vibrations. Now you have to divide throughout by m. So then you will get d square x by dt square plus r by m dx by dt plus k by m x is equals to 0. Now the natural frequency of vibration omega is given by root of k by m. We can write it as k by m is equals to omega square. Now let us take r by m is equals to 2b. Now what you have to do is you have to substitute the value of k by m and r by m in equation 6. You will get this. Okay, take it as equation number 9. So now the solution for this equation is given by x is equals to a into e to the power of alpha t. So here a and alpha are constants. Now differentiate this equation with respect to t. You will get dx by dt is equals to a into alpha e to the power of alpha t. Now again you have to differentiate this. You will get this equation. Now what you have to do is, you have to substitute equation 10, 11 and 12 in equation 9. So in this equation you have to substitute. So you will get a into alpha square e to the power of alpha t plus 2b a alpha e to the power of alpha t plus omega square a into e to the power of alpha t will be equals to 0. Now you have to take common here. So a into e to the power of alpha t you have to take common. So you can write like this. So here a into e to the power of alpha t is nothing but x from equation 10. So from this equation. Okay. So x into alpha square plus 2 alpha b plus omega square will be equals to 0. So now here x is equals to 0 or alpha square plus 2 alpha b plus omega square is equals to 0. So now since x is equals to 0 corresponds to trivial solution, so now you have to consider the solution for this equation, means you have to consider this. Okay. Now the standard solution for this equation is given by alpha is equals to minus b plus or minus root of b square minus omega square. It is the solution. So now what you have to do is, you have to substitute this alpha in equation number 10. So in this equation you have to substitute the value of alpha. Then the general solution is written as x is equals to c into e to the power of minus b plus root of b square minus omega square bracket t plus d into e to the power of minus b minus root of b square minus omega square bracket t. So here c and d are constant which has to be